So hey everyone, my name is Sirish. I run Amazon RDS open source engines, which includes Postgres, MySQL, and MariaDB. And I'm joined by my colleague Yoav Eilert, who's part of our product management team. So first up, huge thanks to Percona for hosting this wonderful event and giving us an opportunity to share our insights on a topic that most of our customers are run into at some point, which is how do you scale and manage your databases at scale? Now, most of you, or several of you, run your databases in the cloud. So Percona invited AWS to share the cloud point of view on this topic. I'm going to telegraph the answer a little bit, or at least our point of view, but I'll assume that if you're running a large number of databases in the cloud, then you're likely already using or considering using a managed database service to reduce the administrative burden, what we would call the undifferentiated heavy lifting. For the purposes of this next 20 minutes, we'll use Amazon Relational Database Service, or Amazon RDS, as the example of the managed database service. But really, the learnings should extend to other public cloud vendors and any other managed services that you use. So what is RDS? It's a managed service that makes it easy to create, set up, and operate your relational databases in the cloud. We have hundreds of thousands of customers using it across any of the 7 database engines that we support. These 7 engines include the 3 open source engines, Postgres, MySQL, and MariaDB. Also, Amazon's own MySQL and Postgres compatible cloud native database, which we call Aurora, and third-party commercial databases. And these customers run these databases both in a public cloud and in a hybrid cloud environment. You have different deployment models you can choose from. So what the scale and diversity of usage really gives us is a vast number of data points where we get really good insight into how customers operate their databases in the cloud, what are the issues that they run into, and how do they overcome them. Now, one other important point about sort of the source of data, right, the source of insights for us, our customers, is that our customers range all the way from individual developers who may have one free tier instance, in AWS speak, that'd be a T2 micro instance, for example, all the way to the other end of the spectrum where you could be a large enterprise running thousands of databases, right? And several of these at internet scale. So if you look at Amazon.com as an example, they are one of our customers, and they use the inventory management system. They use Aurora for it. And over the 11 years that we've been running RDS, we've seen customers move from the left end of the spectrum all the way to the right. And what this really gives us is an insight of how they were able to do it. And those are the best practices that I'll be sharing in a moment. So what are these challenges that customers run into, right? When they start scaling their fleet, when they're not talking about ones and twos, but they're talking about tens, hundreds, and thousands of databases in the cloud. We'd argue that the most important thing that you should be doing if you're responsible for database infrastructure, regardless of what scale you're running at, the most differentiated activity, so to speak, is to be partnering with your application developer partners on making sure that they're getting the most out of the underlying database infrastructure. What does this really mean? You need to be partnering with them on application design, query design, and schema design and tuning. And this is, it's hard work. It requires a lot of thinking. So it takes time and it takes focus. What we find, however, when we talk to our customers who are self-managing databases, as opposed to using a managed service, the ones who self-manage databases spend the vast majority of their time and attention on what we would consider basic tasks, right? Basic tasks like provisioning accounts, users, databases, configuring your databases, setting up your application topology for high availability or read scaling, monitoring your databases, reacting when issues go wrong or when issues occur, setting up your backups, right, and monitoring the backups, making sure they happen, they're valid, setting up your DR setup, disaster recovery, and also your cost management. This is a big part of running things in the cloud, is that you want to make sure that you're right-sized at all times. And not just this, anytime you have to do a change, it's OS patching, database upgrades, or you have a new vendor, new generation of hardware come out, you want to upgrade to it so you get the latest benefits of performance and availability. And all of this stuff the work that self-managed databases require you to do, it's hard work, right? It's important stuff, and it's really hard, and it gets harder still once you scale your fleet, right? It's hard enough with one database. Imagine doing this with thousands of databases. But here's the crucial thing. None of this is differentiated, right? Different does not mean differentiating. And so if you're doing any of these activities in a unique way, I would exhort you to think and ask yourself, why are you doing it differently? It's not different really from any of your competitors, or shouldn't be, because this is not where your secret sauce is. So when you're running databases at scale in the cloud, what's the trick? In a nutshell, our point of view would be that you got to offload all of this undifferentiated heavy lifting to a managed service like RDS, and then you use established best practices for scaling your fleet. Now I'm going to share a bunch of tips, right? These learnings come, like I said, from our customers, and these tips likely apply to whichever cloud you use. But we're most familiar with AWS. So as we go through these tips, we'll call out AWS specific services and features that'll help you implement these tips. So let's get right to it. This is it, 6 tips in all, and we've organized them in the order in which you're likely to encounter them, depending on when you enter the cloud, you start using the public cloud, and when you start using managed databases. Tip number 1, you're beginning to scale, or you're already scaling, right? And one of the most important things about scaling, especially if you're in hypergrowth, and we've seen several of our customers experience that, is you actually don't know what the future is going to bring. And so one of the most important things that you can do in the state is to give yourself flexibility, right? Create as much flexibility as you can for yourself. And a key way to do that is to organize your resources at a very fine grain so that you don't have to come back later and break up the monolith, right? You don't have to go back and break things out, tease things apart. That's a lot of work you have to do after the fact, and it's hard when you're already operating at scale. So start with fine-grained resources. What does this mean? Use separate accounts for different major workloads or different parts of your organization. Use separate dev test from prod. Seems basic, but important. And once you have these different accounts, users at a fine grain, make sure that you're setting up your permissions as well at a fine grain, right? So what we would call the principle of the least need privilege. Now you set up your accounts, you set up your permissions, and they're at fine grain. Now you got to make sure that you're not drowning in fine grain, right? So you got to have some way of creating structure while staying flexible. And this is where tagging is an extremely powerful tool. It gives you a very lightweight way to create multiple flexible hierarchies that you can put on top of these accounts and databases and various permissions. And it's not just about structure, it's also a handy way, for example, to track your costs and do chargebacks and things like that. So tagging, super important. And then the last thing I'd say with this tip is you want to make sure that there's not a hidden cost, right? Now you're talking about multiple accounts. You got a dev test account, you got a prod account. Now, does that create hidden work for you? So we'd say, make sure you understand your managed services or the capabilities of your public cloud vendor well, and see what they give you and take advantage of it, right? So cross-account operations, make sure you understand them, make sure you use them. In the context of AWS, you could use something like IAM to manage your users and permissions. You could use AWS resource groups for tagging. And then in a managed service like RDS, you could use, for example, cross-account snapshot restore, where let's say that you have a production database, it's running in your prod account, you take a snapshot, you restore it into your dev test account, where you could do things like change the schema, fine-tune your parameters. Maybe you're trying something out before you bring it back to production. But that would be an example of an operation that it's just inbuilt, it's a managed feature for you. Tip number 2, you got a lot of resources. Seems kind of obvious. If you have a lot of users, a lot of passwords, lots of everything, it's great if you have a centralized system to govern all of this. It's especially critical when you're talking about authorization, authentication, but also is very useful when it comes to budget management. So we'd say in the context of AWS, use something like AWS Organizations, which is a service that integrates with other AWS services and gives you kind of a central cockpit to manage your environment centrally as it grows and scales. We already talked about IAM. You could use something like Secrets Manager to manage your credentials. And then on the cost side, we offer tools like AWS Budgets or AWS Cost Explorer, where you can track and manage your spend. So, so far, tips number 1 and 2, I'd actually argue they're not specific to databases, right? Anytime you're scaling your environment in the cloud, any service you're using, these seem like generally good ideas. You should be using them. So let's get a little bit more specific about the database part of the story. So tip number 3, this is productionize your database configuration. Now, whether you're using 10 databases or you're using 10,000 databases, one of the most important things, one of the things that drives complexity with managing databases is that databases offer you a huge surface area. And I'm not just talking about the SQL interface that it provides applications, I'm talking about all the knobs that you can use to configure and tune your database performance, and trade off availability, performance, all the stuff that makes databases powerful. A core thesis we have is that regardless of your scale, whether you're running, like I said, 10 or 1,000, it should be possible for you to establish a few archetypes that you can then use across your fleet. These archetypes can be based on instance size. It could be based on the type of workload. You may even have a different set of archetypes for things where you have sensitive data, for example. But you have to think through what these archetypes are for your organization. And like I said, typically there's a handful. And then make sure that as you stamp out new production databases, they fall into one of these archetypes. The fewer the exceptions, ideally no exceptions to these archetypes, the easier it is for you to manage. And that's on the configuration of your databases. The deployment itself, we'd say that treat it like a factory, treat infrastructure as code, and use one of the standard tools that you'd use when you think of infrastructure as a code. In RDS, for example, we offer something called database parameter groups. There's also a variant called cluster parameter groups when you have a clustered database like Aurora. And by default, we offer a parameter group for each database engine, each of the 7 that I talked about, and also each major version within those engines. So something like RDS MySQL 5.7 would have a different custom default parameter group than RDS for MySQL 8.0. But you can take these and you can customize it for your needs, and you can make how many ever I'd say. But like I said, keep a small handful, right, of your archetypes to customize for your needs, and then use these across all of your production databases. And then on the infrastructure as a code, there's many tools that you can use. AWS CloudFormation is one of them. Tip number 4. Sizing databases is one of the hard things about managing databases at scale, because you're continuously trying to find the right balance between not provisioning too much that you're unnecessarily wasting capacity and spend, and not provisioning too tightly so that when you have a spike in your workload, your customers have a bad experience, right? And it's not just about production workloads that are spiky or unpredictable. We sometimes see customers who are not very careful about managing their dev test instances, and you can quite easily pile up the number of dev test instances that are not actually being actively used. And so the question to ask yourself here is, does your public cloud vendor, does your managed database service offer you tools to automatically scale capacity as needed, automatically shut down usage when not being used, and then take advantage of this, right? The obvious gain is you're going to save cost. But the other hidden thing is it's going to save you a bunch of complexity in terms of management burden, right? And really free your time up to do the stuff that's truly differentiated for you. One thing to think about when you're using a cloud native database like Aurora, you get to auto scale each of the different parts of the stack, writes, reads, storage, and IO separately, right? So like I just said, Aurora has different capabilities that come out of the box that let you auto scale. So with writes, you got serverless. With reads, you got auto-scale read replicas. The storage is dynamically done. You don't even have to do anything for it. You can both scale up and scale down. And IOs you use on demand, depending on what your workload needs and what your instance sizes are. If you look at the non-Aurora RDS engines, we offer something called auto-scale storage. You can also mimic the auto-scaling for these other dimensions using a combination of RDS monitoring, which then used to trigger a AWS Lambda function, which then calls the right RDS API to maybe scale up, scale down, do the things that you want. Tip number 5, probably the biggest one, and goes back to what I said at the beginning, which is that when you have a lot of databases and you're already operating at scale, the most important thing we think you can do is use the capabilities that your public cloud vendor is already giving you. Whether this is to set up your HA configuration, read scaling, logging, monitoring, backup, DR, patching, if it's coming for free, use it, right? Because then that frees you up to do the things that are special for your company and for your customers. With RDS, for example, we offer multi-AZ deployments, which means that you can have a single database that has a primary and a secondary, which are located across 2 different isolation zones, two zones with different fault tolerance characteristics, but in the same region. And you get automated managed failover from one to the other. So use that. You can also use managed in-region replicas. With RDS, you get up to 5. With Aurora, you get up to 15. You can enable database logs. It's just kind of a checkbox if you're using the console, or you can use the API as well. And you can upload these logs automatically to AWS CloudWatch logs. Same with monitoring. You can set up monitoring fairly easily, and you can upload all these metrics to AWS CloudWatch monitoring, CloudWatch metrics. RDS offers automated backups, manual snapshots. If you want to set up a DR, disaster recovery, we offer a cross-region read replica, which is automated and managed. With Aurora, it's got something called global databases, which offers superior RPO and RTO, so recovery point objective and recovery time objective. From a patching perspective, we'd recommend turning on auto-minor version upgrades. So this is a facility where you automatically get patched up to the latest, what we call preferred version, something that we've tested and we've made generally available. And it happens within your maintenance window. So you don't really have to think about it. It's something that you get free. And again, you get the security fixes and all the other fixes that you want for your database. The last tip I'd say is databases don't live in isolation. As I mentioned, they have huge surface area, right, for the applications above them. And it's critical that you understand the interplay between the app, proxy, and the database layer. Simple examples, make sure that your timeouts cascade the right way between statement timeouts, connection timeouts, application level timeouts. If you have a database restart, make sure that you don't restart all your connections at the same time, because that could cause a connection storm, right? From a monitoring standpoint, don't just look at system metrics, right? Like CPU usage, that's important, but also look at performance on a query level, so that if something goes wrong, you can be fairly surgical about identifying where the issue is and go fix it. And then if your public cloud vendor offers you a choice of cross-stack operations, use them. So again, in the AWS context, a service like RDS Proxy will help you with connection management, amongst other things. You could use the performance insights feature. It comes with RDS. You just turn it on to get performance at each SQL statement level. And you could use a tool like AWS Backups that operate across your stack to take a backup of your entire stack. So that was a lot of ground to cover, whirlwind. So I'll just leave you with one closing thought, which is databases are complex pieces of software. They have a wide surface area, both in terms of SQL and in terms of the configuration and tuning. And they can interact with your application in a myriad of ways. When you're running a database in the cloud, at any scale, but particularly at large scale, take advantage of the public cloud capabilities and offload all the undifferentiated heavy lifting to the public cloud vendor so that you can focus on the secret sauce that makes your company great. Thank you.